Okay guys, in this tutorial we are learning how to give aliases to structures and also other data types, individual lines when we have them down there. So anyway, because from last tutorial we have this structure, this piece of code, let's give it a handle, let's give it alias to easily have mentally that representation when we have bunch of code before a main piece of a program. So right here we are going to say Typedef. That's a new keyword we are learning, Typedef. And here between ending curly bracket and semicolon we are going to have that alias for this piece of code. So let's say that generic book will be alias for this piece of code that we can use down there. So will this stuff work now without changing anything in the main? It will, but that's not correct way of solving things when we have Typedef. So here we will not say struct books anymore. It is just enough to say generic book. And now at least you don't need to type struct and the name of that structure, just handle generic book. And this thing right here will remain totally unchanged. See, it works. Let's recompile it couple of times, rebuild to make sure. There you go, 2-3 times that code is absolutely changed, and build and run, and there you go, absolutely same stuff. So remember, when usually you're gonna use this with the structs, especially at the beginning of programming career. So on the left side of struct, a little bit of space, and Typedef totally at the left side. And if you have Typedef keyword right here, you must have handle for this piece of code. And if nothing else, down there you don't need to type when you're creating individual entry, like in that imaginary table. You don't need to type struct books, book 1, and so on and so on. Just generic book, like a handle and individual entry, real stuff, and that's it. At least no that much typing. So some people are confused maybe right now because this piece of code. So anyway, let's just delete it and do individual aliases for our own data types. So I'm gonna, for simplicity reasons, delete this. And yeah, let's delete this. Okay, but I think that you get the point here, at least visually. So what if we wanna create character, but our own character? Something like a constant that we can use down there. It's not constant, but something like it. Alias for our own data type. Let me type that to Typedef, for example, for character. So Typedef and then data type in pure C, and then handle for that our own data type that we can easily remember. For example, here you can use lowercase, but it's customary to use uppercase when you're working with the Typedefs. I mean, it depends what kind of source code you are writing and reading from which books, but usually this is uppercase. It depends. So when we compile this, nothing happens because we are not using this thing down there in the main. So let's use it because right now we have it, our own data type, alias. So right here we are going to say that based on character, our own character, handle, uppercase, we will create some variable, let's say only one character, only one, and the value will be, let's say, a. So can we use it? Of course, that's the whole purpose of it. Print f, and what was the original data type in, let's say, pure C? Well, percent %C for like a normal character, a little bit of a new line, and concatenation with only one. Only one. I don't know how to type, sorry about this. Only one. Okay. And now this will A will be on a screen. There you go. So based on this your own data type, where basic data type is a character, you can also say, okay, give me another one. Okay, only one, but this will be second one. let's say, and the value will be R, let's say. And down there we are going to print that second one, and the result will be R A and R one after another. There you go. So it's cool stuff to visual, like how to visually faster grasp stuff on a screen. Um, let's create another typedef for again character because it's easier to remember. Typedef, and again the base, pure base will be character, and let's have like a line that can be in header. Of course, you can do this with the constant defined like a keywords used in a C and C++, but here you can have alias for that too. So long line, and because this is bunch of characters, it's actually string, so we must use this type of brackets, right? So this is base for stuff that we are going to create down there based on our own long line quote data type. Long line is absolute base. So what will be real stuff? Well, let's say we're going to give it a name like a header start equal, and just as when you're creating string, couple of these lines, because this is a string because of this this piece of brackets and semicolon, and now we have this header start, which is based on a long line, which is based on character. Well, some people will say, well, what's the point of that? Well, it is just important to know that you have this concept, and when you're browsing source code on internet, you're gonna run into a lot of these files with typedef this and typedef that. Variables. Well, yeah, let's use it. Printf, and what is original data type? Yeah, it is character, but it is a bunch of characters like string, so %s for string, and new line, and concatenation with target, which is header start. Header start. Okay, will this work? Let me see. There you go. We have these this weird header. Okay, can we do like a calculation based on that, like a surface for rectangle based on width and length, of course, but with our own data type? Well, sure. Both of width and length, or x and y, represents same data type, which is integer, but based of like its number. So it's a size. Both of w and l are sizes when you think generically about it. So typedef base type is integer, and x and y, or a and b, or width and length generally are sizes. So this is our own, let's say, data type, right? Sizes, we are calling it like that. So down there, based on sizes, we're gonna have individual width, and the value will be, I don't know, 10 millimeters or centimeters or kilometers, whatever you like. And also sizes will be base, and base of that will be integer, and that is for L, for length, width and length, and the value will be 20. So down there we must have integer area, which will be a result of multiplication of course, x and y, or w and l, or a and b, whatever you use for variables, and then we can use it. Printf rectangle surface, and this will be originally integer, so d, and a little bit of new line, and concatenation with that end stuff, which is area. Area holds result of calculation of w and l, and base of that is the sizes, our own sizes. That's how to differentiate visually in source code, I think. It depends how you think. And that sizes is generally integer, or it can be float, double, whatever you like. So yeah, this is semicolon, and now rectangle surface will be 200. Where is that thing? Oh yeah, there you go, rectangle surface. And again, if you want to have this header, there is no need to like type it anymore like this, like hard coded, because you always have it based on long line. So you will just grab this thing, or even to create function that will do this thing, you can do that on your own for practical purposes. So we are going to put this, let's say, right here. So you're just printing that header start. Okay, there you go. So probably you get the point here. If you want to use your own aliases for data types to easily remember how much of them you have and where they are used, then use Typedef and a base C data type, and then how you think about it and what they do, and then use them down there. So here, when we are creating variable based on our own data type, based on basic character, we can create that variable, populate it with data, and then use it down there. Because C and C++ source code can have thousands of lines. So it's cool to have these Typedefs on top of the file, alongside with the constants and stuff like that, and the listing of functions, so you can just glance to it and know what kind of stuff from here you can use down there. So it's like a reminder. I think that's cool. If this is kind of confusing, then try just to do like calculation of area or different geometrical shapes, and don't mess with characters, because I think it's easier to work with geometrical objects. Because you have formulas on Wikipedia, and maybe you know them if you are fresh in school and from school. So yeah, this is basically easier visual representation. Right. As always, thank you for watching. Thank you for support and subscription. Share this channel with other people. You're gonna help them, you're gonna help me, and see you in the next tutorial. Ciao.